DeepCell is a novel provider-side fingerprinting localization system that achieves high-accuracy localization for any cell phone, regardless of type or generation, by leveraging unlabeled cellular measurements recorded by the cellular provider. Unlike client-side fingerprinting solutions, DeepCell opportunistically synchronizes with selected client devices to obtain location labels, enabling ubiquitous deployment and accuracy. The system addresses challenges such as handling unlabeled data, noise and sparsity, scaling to large areas, and providing sufficient training data for deep models without overhead. DeepCell's system architecture consists of two phases: offline training and online tracking. During the offline phase, the provider's cellular data is used to build a fingerprint, which is then used to train a deep neural network model. The provider's cellular data contains records of phone events, including cell tower changes, with each record consisting of event type, timestamp, phone ID, active cell towers, and neighboring cell towers information. The system's modules, including the offline spatial augmenter, grid generator, model trainer, data collector, and online data synchronizer, work together to collect GPS traces, synchronize cellular measurements, handle noise and sparsity, and train the deep neural network model. Evaluation of DeepCell in a realistic environment shows a consistent median accuracy of 29 meters, outperforming state-of-the-art client-based cellular localization systems by more than 75.4%. The system's zero extra energy consumption compared to normal phone operation makes it an attractive solution for accurate and energy-efficient localization. DeepCell has significant implications for various mobile applications that require outdoor position information, such as navigation systems, location-based advertisements, and emergency services. DeepCell is a novel approach to cellular-based localization that utilizes deep learning to provide accurate location estimates. The system consists of a data collector, spatial augmenter, and grid estimator modules. The data collector gathers cellular measurements from various cell towers, while the spatial augmenter generates additional data points to enhance model robustness. The grid estimator module employs a trained deep neural network, specifically a multinomial logistic model, to predict the user's location based on input cellular measurements. This model learns the relationship between input features and grid cells' probability distribution through training, with dropout regularization used to mitigate noise effects. During online user tracking, DeepCell relies solely on phone ID as input, estimating the discrete grid cell and refining the location using a fine estimator module. The system's performance was evaluated in a 2.04 square kilometers urban testbed in Alexandria, Egypt, demonstrating accurate location estimates and outperforming state-of-the-art techniques. The impact of various parameters on DeepCell's performance was studied, including fingerprint models, grid spacing, augmented samples, cell towers density, training epochs, and learning rate. The optimal deep network model structure consists of 3 hidden layers with 256, 128, and 64 neurons, yielding consistent accuracy. DeepCell's accuracy is enhanced by incorporating active cells information, spatial augmentation, and cell towers density. Experimental results show that DeepCell achieves better localization accuracy than state-of-the-art systems, such as DeepLock, by more than 75.4%. The paper highlights the limitations of GPS-based and sensors-based techniques and the advantages of DeepCell's energy-efficient and ubiquitous coverage. DeepCell is a provider-side cellular-based localization system that leverages ubiquitous cellular network coverage to provide high-accuracy localization for any cell phone. The system builds a radio map from provider cellular unlabeled data and employs a deep neural network model for localization, capable of handling system challenges and noise in the input data. This approach yields a median accuracy of 29 meters, outperforming state-of-the-art cellular-based localization systems by more than 75.4%. DeepCell draws inspiration from Wi-Fi-based localization systems like dynamic SLAM, which utilizes human anchors for low-overhead indoor localization, and outdoor cellular localization systems like DeepLock, which achieves high accuracy with low overhead. The system's neural network architecture incorporates dropout regularization to prevent overfitting, as introduced by Shrivastava et al. The network is trained on a dataset of cellular signals and corresponding locations, enabling it to learn complex relationships between signal patterns and geographic locations. In contrast to traditional fingerprint-based outdoor localization methods, DeepCell employs a crowdsourced approach, leveraging mobile devices to collect signal data and provide location information. This approach is more energy efficient and scalable than traditional methods. The system's accuracy is evaluated using a dataset of cellular signals and corresponding locations, demonstrating high accuracy in both urban and rural areas. DeepCell outperforms state-of-the-art localization systems, including VTrack and Horus WLAN. DeepCell's advantages include its ubiquity, accuracy, and low overhead, making it suitable for various applications, such as location-based services, traffic monitoring, and emergency response systems. However, the system assumes the availability of cellular signals and relies on the quality of the crowdsourced data. Future work includes exploring the use of other sensor modalities, such as GPS and accelerometer data, to further improve the system's accuracy and robustness.